Hello everyone, my name is Suvasis. In today's session, we are going to talk about workflow orchestration. The tools that I'm going to use is Apache Airflow, and most important, I'm going to use Astronomer, which is a managed service for Apache Airflow. This is going to be part one, and part two, which will be a separate video. In that, I'll cover how you can call pipeline developed in Kubeflow, and you call that from Apache Airflow. So it will be slightly complex use case that I'll cover separately in part two. Let's focus on part one. First things first, I'm going to show you how you install Apache Airflow by installing Astronomer. Under the hood, it will deploy the different components of Airflow, and for that, it will be using Docker. So the very first step would be installing Docker desktop. I'm going to use Mac operating system. So you will see very quickly the Docker being installed in my Mac, and then after that we'll go for Astronomer installation. First of all, why are you going to use Apache Airflow? So as the very first page, it says Airflow is a platform created by the community to programmatically author, schedule, and monitor workflows. Okay. What are the kind of use cases that the Airflow would be able to cover on a day-to-day basis? Let's say I'm a QA engineer, and then I'm doing some sort of uh, extraction of different data from different sources. So that is extract, and then I transform the data. I make it much more meaningful, much more cleaner. I clean the data. I transform the data to make it more structured for a particular use case. It could be as simple as loading that data into file, could be CSV, Parquet, anything, or it could be updating set of records in an existing table or inserting set of fresh records in a table, either new table or an existing. You create a new table or you update in an existing table. So that was like normal ETL extract transform load scenario, or let's say you want to run a ML machine learning pipeline, right? The very first step would be, of course, extract, right? You have to source the data from different sources. It could be one or more sources from which you will source the data. And the second thing you'll be doing is once the data is extracted, you will pre-process, right? That is the kind of transformation step. You might be cleaning up the data. You might be doing some exploratory data analysis EDA, or you might be in conjunction to all those things. You might be transforming the data. You might be creating new features, right? Based on the subsequent steps that would be using that data that you are processing in the pre-process or transform state. So your very first step was extract, second step is pre-process, and the third step would be machine learning model training, ML training, where you try out different algorithms with different ML algorithms with different set of parameters, and then you train and you record the error metric and figure out which particular model is giving better accuracy. So that would be part of your ML training pipeline step, where the final models then you persist for the scoring step, which would be the final step, right? Uh, so in the scoring step, you will utilize those generated trained models, and you will run it against the actual data that is coming from the source, and then you will get the final forecasted values. Once you are kind of satisfied with this whole pipeline, you will go for deployment, right, in production. This could be another use cases for pipeline. Now, all these pipelines, right, that we are talking, the individual steps, without, what happens if you don't have any workflow orchestration tools on engine like Airflow. If you have used Azure, then the parallel service for from Azure is Azure Data Factory. I'm very much sure, like in AWS you'll have something like Glue, and so on, so forth. Now, So without the existence of this orchestration engine, you might be running these steps manually. Now that could be cumbersome. Running all these steps manually, even though you're running it a couple of times in a day or a couple of times in a week, so frequently, even then you are doing this all these things manually. So manual hand holding, monitoring individual steps, and then running the subsequent steps. You have to handhold all those steps by running them manually in that sequence. When you have tools like Apache Airflow, right? Even better Astronomer, which is kind of going to abstract. You'll see that in a few minutes from now. The Astronomer will uh, abstract the whole deployment of Airflow components. The nitty-gritty of those things will be completely abstracted. With that, so these individual steps can be put in a pipeline in the form of directed acyclic graph. So, every node in that graph would point to the next one or more steps. And in that whole graph, you will not find any cycle. That's the constant that you'll have to follow. Right? It has to be a DAG. There should not be any cycle in that whole pipeline graph. So with these engines like Apache Airflow or Azure Data Factory, you should be able to run those pipelines like in the DAG format, and that makes your life much easier in terms of you can schedule that whole pipeline based on the frequency as per the used technical or business use case. And Yeah, you don't have to manually handhold those, one or the one step from the other one, running those steps in that order. So with that, now that we understand in a very basic form what is Apache Airflow, what is Astronomer, and what kind of problems it solves, let's go towards the part one objective. This is the repository that I have created, and the root of the workflows orchestration is having a couple of folders. It might grow at certain point in time, but right now, as I record this video, today I'm going to cover part one, which is Astronomer Airflow. Let's get in there, and then you can see all the steps that I'm going to follow. The first step is install Docker Desktop for Mac. Uh, I have the link, so you can navigate to that link and download the respective installer for your operating system. In case you are using Windows or Linux, go for the relevant steps, right? This part is already installed, as you can see here. It might take a while, so I have already installed. So my very first step is done. Now let's move towards the second step, which is install Astronomer. Again, the steps are documented here. I'm using Mac, so I'll be following that. Uh, Astronomer is installed by this command already in my system, and if I run astro command, it will be available. So this step will cover that. Right. The next step is you can skip these steps. Okay. Next thing is we want to run the Airflow locally, and for that I said Docker should be already installed, which is there for me. Right. The step that I'm going to run now is astro dev init. Okay, I'll edit this. It should be in, this should come to the next line. So let's do that. What this will do is it will initialize a new project. Okay, empty project. You can see the skeleton of the project, the scaffolding of that project is created. If you go to DAGs, you might see some sample DAGs. Even if you install Airflow locally, right? You without Astronomer, then also you'll find this, one or few tutorial DAGs will be created so that you can verify few sample DAGs. The next thing I'm going to do is astro dev start. So this will run, let me run this command. It takes some time. This will run this continuous Postgres web server scheduler triggerer, right? So if I go to my dashboard and if I search for astronomer related, you'll not find anything. Now they're getting initialized. As I run this command, it will pull those images, container images, and then it will initialize those containers. Okay, it will run those containers. Primarily, these four containers will see they'll be running. Let's give it a few minutes to complete. It has been a while that we ran that command to initialize the astronomer components. Okay. You can see the command has finished. Let's go to the dashboard for Docker, and here if you search for Astronomer, you can see the containers have started running. Okay. Postgres, scheduler, triggerer, web server. Web server is the component that will show the UI interface. Scheduler is the one which will do the scheduling of those DAGs. Postgres is the backend database, and triggerer is something uh, probably used by the scheduler to trigger the jobs. Okay. Let's go back and use the home page for Astronomer. I have mentioned the default user is admin/admin. Let's try with that. There you go. So you can see the template DAGs that I showed you earlier. Example DAG advanced and example DAG basic. Those two DAGs are already available. Right now they're in pause state. Okay, they're not running. If you want to run them, you can trigger from here. Let's do that for now. Otherwise, it will run based on its scheduler. So as you trigger this, I'll go to the DAG run page. You can see the first step, which is extract in this case, has finished. Now, if you want to visualize the how the DAG looks like, right? You can come to this graph, and then you can see the major steps are there: extract, transform, and load. So the whole thing is called DAG, and these are tasks inside that. Right now, in the current pipeline that I have run, you can see they have all reached to this success state, borderline with this dark green color. And you can go to individual, you can look at the code for the DAG also from here. This is the DAG definition using the @DAG annotation. This is the definition. These are some configuration for the DAG, like what is the schedule interval and few other things. Retries. If it fails, then how many times you are allowing it to retry. Example DAG basic definition starts from here, and the task annotation will mention this is a task. Extract is a task. That's what you saw in the visual diagram also. Extract, transform was another task, and then load was another task, and then you put the implementation in those individual task definition, right? And finally, we'll call them like order data equals to extract. So you call extract, transform, and then load. There are other ways of calling the DAG that will show in a few seconds. Just go there, and I wanted to show you the execution log, right? So if you look at the if you look at the code one more time, then you will see in the load state it prints a statement: total order value is something. So let's look at the log for load. You can click on that statement log link here, and here you will see total order value is this. So the DAG has successfully completed, and right now it is in unpaused state. So based on its next run schedule, it will trigger at next run time. Right. Right now I'll keep it in paused state so that it does not run any further. You can see active is one, paused is one. All right. So that was the first step. How you install Airflow using Astronomer and running the basic DAG. In our state, the next thing that we're going to do is create a new DAG And for that, I'll go to our repository DAX folder and download these two files. Okay, let's copy this and go inside our DAX folder, create that file. What was the name of the file? I'll give the same thing, Airflow tutorial basic py. The other file was simple.py. This file is being referred from inside the main DAG file. This is not really a DAG file, right? This is another utility file which is being referred from within the DAG file that we already created. Okay? So our DAGs are created under the DAGs. So this is important, right? Uh, so now if I do DAGs, you will see Airflow tutorial basic DAG and simple.py, and they are under DAX folder. It has to be under DAX folder, then only those will be synchronized by Airflow, and at, at some frequency, they will keep on looking at the DAX folder, and then it will bring those newly created DAGs to this page, right? Sometimes your DAG might have some errors, parse errors, syntax errors, and in that case, Airflow will show you if any errors are there at the top of this particular DAX page. So right now, if I refresh a couple of times, does not bring. Now I want to test this particular step. So what I want to test is astro def restart, right? Or I can try astro def kill and then astro def start. This is this is a hybrid command, astro def restart, which will do the kill first and then start, right? So let's do that. Before that, one final time, I'll just check if the DAG has come or not. So it has not come yet. Let's go to the terminal and say, and this command has to be run always from the root folder from where I have initialized the Astro project, right? So now I'll say Astro dev restart, which will kill the current, it will stop the current contents, and again it will bring them up. And it will refresh the DAX from the DAX folder, right? Let's give it few seconds. All right, it took a while to restart the containers, but no issues. There you go. So the command has successfully finished, and we'll have to re-log in. And there you go. The new DAG is listed. Airflow tutorial basic DAG. That was. It's not necessary like this file name has to match with the DAG name. It's not really necessary, right? What it brings to the Astronomer DAG space is primarily this one. See that quickly. So this is our DAG that we are now looking at with DAG, and then you mention whatever you mention here. That's what you'll get to see here. Airflow tutorial basic DAG, Airflow tutorial basic DAG, right? However, it's a best practice to keep this particular DAG name same as the file name. And if from this DAG, I'm calling something like from simple import print simple. This is a custom Python file that I have created here, and from there I'm referring one file. That's why both the files should be present. We'll go back to this definition quickly and run through this. So in this, you can say as DAG, and here the DAG definition starts like print context is the function, and I'm having a couple of tasks like Python operator run this two, bash operator run task 3, right? What is the difference, right? Now, Python operator, bash operator, these will run locally within Airflow's own workers. So Airflow, it will have something called executors, right? And there are different form of executors like local executor, celery executor, Kubernetes executor, so on and so forth. You can go through the Airflow documentation. If something you are using, running using Python operator or Bash operator, they will run within Airflow's own worker nodes, right? And if you're running something, let's say by Kubernetes pod operator, data proc related operators, they will go to their uh, relevant Kubernetes cluster outside the Airflow's installation or data proc cluster outside Airflow's installation. So based on the operator types that you're using, it will depend on where that particular task will be executed. Is it within Airflow's own workers, or is it outside Airflow in some Kubernetes cluster, let's say in GKE or in Azure AKS, or some other external Kubernetes cluster, right? So this, and then finally here you are seeing, right, run this equals to print context. You run this function, and then after that you are running this particular task, run this two, and then run task three, right? So you can chain different task execution like this also. This is another form of how you execute your task. And if you want to run, let's say, task 2 and task 3 in parallel, then in that case, after this double arrow, we'll put a square bracket, run this 2, comma, run task 3, and then close square bracket. So that way, your task 2 and task 3 will become parallel. They will not be sequential. Let's go and look at the definition of it. In the graph form, you can see print the context, print simply using Python of echo task using bash of. So from where those texts are coming, you can see here. So here is your print the context. That was the first step. The second task is print simple using Python operator. And the third task is echo task using bash operator. Right? That's how you define your pipeline. Now if you run this again manually, you can see right now it is not even okay. It is already success. This one is success, dark green color. This one is currently running. You can see the light green border around it. And now it is successfully completed. You want to see the log? You can click on individual step and say, look at the logs. Now, whatever you are returning or printing, they will come here as in log messages. So from the first step, whatever you return gets printed in the log, and that's what you could see here. Whatever you return gets printed in the logs. For the second step, right? So I can navigate in either way. I can come here and I can go to my individual step. So I have looked at the log from the first step. Let's go to the second step and click on its log. So let's see what it is supposed to print. So it's calling using Python operator a Python function print underscore simple, and that is being referred from the uh, this particular simple Python file, and then the function print simple. So it will just simply it will just simply print simple this text. Let's validate. If you are seeing that, yes, that's the message. And the third step, which is echo task using bash operator. And let's look at the log for this one. So here, this is the command bash command that you're running, bash minus c echo message from echo task using bash operator. And that's what you will see, message from echo task using bash operator. So that's how you can define your own tags, and you can schedule them. You don't have to do any manual hand holding of those. Okay, that's pretty much it. What I wanted to cover in the part one. Uh, Stay tuned for part 2 where I'll cover slightly more advanced topics. So if you are a machine learning developer, right, you might be comfortable creating your machine learning pipeline using Kubeflow, which is on top of Kubernetes. So you can define your ML pipeline using Kubeflow, right? And then the overall orchestration, it might have few more steps, right? You may have some uh, extract step where you are sourcing data from different sources. Now that, let's say that is a step in your Airflow pipeline. So you want to combine the pipeline of Airflow along with the pipeline of Kubeflow, right? Intermingle. That is slightly complex topic and we'll cover in part 2. So please stay tuned. Thanks for watching.